Okay, find the value of k that makes the following function continuous. Graph the function. Okay, so we have two different functions here. One function x squared minus k exists where x is less than -1. The other function 2x minus 1 exists where x is greater or equal to -1. If I want to make it continuous at all points, I need to look at this interval. So if I'm looking at this interval, I need to look at the end value of each interval, right? So f of -1 should not equal -1 squared minus k, because this interval up top here should only exist where x is less than -1, so it doesn't equal -1. So f of -1 should not equal 1 minus k, right? But f of -1 here can equal the second function here, 2x minus 1, 2 times -1 minus 1, which is -3. So f of -1 can equal -3. Now, by itself, there's going to be a hole at this point. So there's basically a hole or a point discontinuity. Well, it should put hole as in quotation marks. There's a point discontinuity that occurs at -1 and 1 minus k, right? So because there's a point discontinuity, the function would be discontinuous. If we equate this value with the -3, then the function will be continuous again. So I'm going to let 1 minus k equal -3. If I move the 1 to the other side, -k is -3 minus 1. -k is equal to -4. If I want to solve for k, I'm going to divide by -1 to both sides. K here is equal to 4. So if k is equal to 4, then the piecewise function f of x will look like x squared minus 4 and 2x minus 1. X is less than -1 and x is greater or equal to -1. You can notice here that at f of -1 here, it shouldn't equal -1 squared minus 4, which is -3. But f of -1 here can equal 2 times -1 minus 1, which is -3. And the hole, which is this value, is basically being filled by the other value of the function. Okay, so that's where all points will become continuous.